So 6 million registrations in 30 days are the story of how Chick-fil-A won, scaled on AWS. So again, my name is Andrew Baird. I'm the solutions architect with AWS, and I'm joined by Chris Taylor from Chick-fil-A, who's gonna come on stage in just a few minutes to share the specific story that Chick-fil-A experienced while bringing their mobile app, which I assume a lot of you have on your phones right now and have probably used already in the past 6 months or so. What that process was like for them. But before we jump into that, what can you expect from the whole session in its entirety? I'm going to get started first by talking about one of our core services that plays a pretty big role in a lot of mobile app launches for our customers, and that's DynamoDB. Give you some advice about the way in which DynamoDB can help your mobile app scale to the same extent that Chick-fil-A was able to do with theirs. And then Chris is going to come on stage and provide a lot of context around the story for their app launch, give you an overview of their architecture, talk about specific lessons learned during the process of the launch phase for the application, so that you, as folks in the room who may have similar aspirations to launch a large-scale mobile app, can learn from their experience. And then I'll talk about a peek into the future for some plans they have to build into the app as well. So let's jump in. For anyone that's not familiar with DynamoDB, it's one of our older services, so hopefully everybody's worked with it or is at least familiar with DynamoDB. But it's a non-relational NoSQL database service, fully managed. Service is underlined here because this isn't a piece of software that you're installing on a set of EC2 instances that you've got to manage, that you've got to scale yourself. It's offered to you through an API as a service. And from a mobile development sense, as a mobile developer, what that leads to for a lot of our customers is this huge love story between mobile development and DynamoDB, because a lot of mobile app developers, the last thing they want to do is get into the business of worrying about NoSQL infrastructure, how to scale it. There's a lot of NoSQL technology that might be really easy to get up and running when you start, but as soon as your app hits scale, it becomes a scaling bottleneck for your application. And DynamoDB is a great way for you to build an application architecture for your mobile app where you don't need to worry about how you're going to scale your infrastructure once your app scales and your users come along. What are the reasons? Why does this love story exist between mobile dev and DynamoDB? I'm gonna highlight kind of how the tenants of the service and some of the features and functionalities are directly related to the tenants that a lot of mobile app development teams have. So I've alluded to this a little bit, but one of the core tenets of DynamoDB is to take all ownership of the scaling process away from you. You only provision and you only pay for the capacity you require. So obviously, the economics of DynamoDB are a great benefit too, that while you're beginning to develop your mobile application and you don't have any live users yet, but you need full functionality, you only provision the capacity that you require from the service, and that's all you pay for. And once that scale does come along, once you're preparing for your launch, a simple API call is all you need to do in order to have the service on the AWS side fully scale out and be able to support whatever traffic you're expecting. And if you see more traffic than you expect, it's just another API call away to make sure that your NoSQL database infrastructure is giving you the capacity you need. You don't need to worry about, once that scale hits, developers on your team having to take them off of product development and new features for your customers and dedicate them to figuring out how to scale a complex piece of database infrastructure. You just make those API calls and let the team on AWS that built DynamoDB give you all of those benefits while letting all of your app developers stay focused on building features and functionality. And the next part that really makes it a very attractive service for mobile app development just getting started is this combination of a choice between taking advantage of these really dead simple capabilities at scale that DynamoDB provides. You can see a little code snippet here that's a piece of code to put an item in a DynamoDB table that would scale to near infinite levels and also be the same bit of code that you'd write when you're just getting started with your mobile app. And you're inserting some test data. It's a dead simple API that you can get started with. But as your application grows and your users demand more features from you, it has a lot of robust depth and deep functionality behind the scenes that's available for you to take advantage of. Just like the rest of AWS's services, there's a lot of features and functionality that are there for you to consume should you need them, but it's your choice. Whatever your app requires, you decide which features and functionality of the service you need to take advantage of. So I've listed a slew here. I'm going to focus on just a couple of these that I think play a great a great role in a mobile app use case. So the first one is the idea of fine-grained access control. So if you're familiar with the concept of IAM roles and policies, one of the really cool features of DynamoDB is the ability to create IAM policies that get extremely specific and fine-grained about what that role has access to in a DynamoDB table, down to the attribute level, to the record level. So when you combine a mobile app use case where you might have a unique customer identifier that represents the primary key in a table, you can set up an IAM policy that says the queries for that user with this primary user ID only has the capability to query records that are primary keyed on their own user ID. From their mobile app device, say you're using our Cognito service for identity management. That Cognito ID associated with a specific user might also be the primary key in a table, and the only queries that their device would be able to execute are the queries against attributes and records that are tied to that primary user ID that was given from Cognito. So really, really fine-grained stuff you can do. If you're running a mobile app that has a freemium model where you have a lot of free functionality available, but you're tracking metadata and user state that eventually, if the user wants to take advantage of, they can pay into a more premium model, you can use fine-grained access control to restrict the ability for some of those attributes to be requested out of the DynamoDB table. And then once the level of user changes, if they become a premium user, or if you have separate clients, maybe business clients that you want to allow them to pay to have more access to specific data, they can be given an IAM role that gives them access to more attributes in the table. So really fine-grained control over what your access model looks like for your data. The second one that I'm going to go over is the idea of DynamoDB streams. So even though you've got this NoSQL database as a service that can run at infinite scale, the idea of creating a transaction log of all of the updates and records that's happening within your database isn't necessarily a new piece of technology, but what's incredibly robust and really cool in my mind here is not that there's a transaction log that's completely strictly ordered and can be delivered exactly once, but we also provide the glue for you to have that transaction log programmatically delivered as events to a Lambda function. So with no infrastructure, piping to manage yourself, how to hook those two things together, with a very lightweight development process, you could write a Lambda function that's going to programmatically receive as an event all of the updates and all of the puts and that have happened in your DynamoDB table. So there's really cool features that you can implement with this type of technology for your mobile app. That your NoSQL database table is existing and being interacted with the same way it has always been from your mobile app. The live traffic's going in your table, but maybe there's a lot of asynchronous functionality you want to build behind the database table, not using capacity that your mobile app is leveraging, but building all this functionality asynchronously against a stream of data of all those transactions that are being exposed through a DynamoDB stream. And the last bit, the most important tenet of the service, is that all of these features, all this functionality at any scale, the number one thing with DynamoDB is that the performance is dead steady like a rock. You can see, that you might have even seen this graph before, it's pretty popular with DynamoDB. No matter the scale that you're experiencing, the fluctuations you see day to day, it's DynamoDB's number one duty to make sure that the latency and the performance is there, which is obviously really important in a mobile app sense where the latency to make a call back to a persistent data store that's living in AWS, offloaded from the mobile device, latency is of the utmost importance. A slow and unresponsive mobile app is about the number one deal breaker that will have a user stop using your app. So to step away from some general recommendations and overview of the DynamoDB service and how it fits into the mobile app use case, I'm going to next just give you a couple examples of literally from a mobile app use case for large scale, extreme scale mobile apps. What are they using DynamoDB for? What kind of data are they storing in it? How do they leverage it within their architecture? So I'm going to highlight these 4 types of examples. So first and foremost, I've alluded to it already, a table that's keyed on primary user IDs, where you're able to store things like contact information, user preferences, whatever metadata is important to your application that's associated with a user. DynamoDB gives you a way to very quickly, with extreme low latency, access that data about a user, no matter the number of users you're supporting. So if you need to scale to 6 million users in a month like Chick-fil-A did, then obviously the ability to retrieve that user data quickly is going to be a core part of your functionality. The next piece is it's a great way to offload session or app state. So if you're building a mobile game and you need to track state of the metadata around what level a customer's on, if you want to be able to implement a multi-channel experience where the same user ID is able to interact with your app or your game on multiple different devices or channels, storing session state or app state centralized in DynamoDB is a great way to enable those types of activities. The next bit is transaction metadata. So any transactions that happen, whether it be a financial transaction or interactions with your application, friend requests, whatever would mean a transaction in your application, having a really robust way to write that data at scale, to read it back at scale. It's what a lot of our mobile app customers are using DynamoDB for. And then the next one has been a really popular use for DynamoDB, not just in the mobile space, but in general on AWS. And obviously, hopefully everyone in the room is familiar with the value that Amazon S3 provides as an object store. But it doesn't really provide the same type of performance characteristics when you need and query capabilities that you would get from a NoSQL database like DynamoDB. So one of the most popular ways that DynamoDB is used in a really interesting way is to have things like your media files, large order records, whatever's important to your app that wouldn't make a good fit to store in DynamoDB. Maybe it's too large to fit in DynamoDB. Maybe the data types don't make sense to store in a NoSQL database. But you can store a lot of indexed information on primary keys, and one of those attributes you'd store in DynamoDB that you'd query for would be the key ID for where that object lives in S3. So maybe you've got users that are uploading a slew of different media files, images, videos. You'd like to be able to quickly access those things when they bring up their profile page or their friends list, and you need to load a bunch of thumbnails and profile pictures, rather than being able to index where all those things are in S3 directly and keeping that list somewhere. You can store primary keys inside DynamoDB for all of the metadata associated with those images, including a URL or an object key for where that lives inside of S3, so that you can quickly retrieve the list of those object keys in S3 and then pull them directly from S3, because hopefully a lot of folks know the scale with which you can retrieve data from S3, the size of the objects you can store in S3 is going to far surpass the type of object size that a DynamoDB record would support. So 4 really popular ways in which DynamoDB can play a great piece, a great role inside your mobile app. And with that, I'm going to hand the clicker and the stage over to Chris Taylor from Chick-fil-A, and he's going to give you an overview of their story here.
Thank you, Andrew. I am Chris Taylor. I'm responsible for the technology behind Chick-fil-A's customer-facing systems, and I'm really honored to represent the work of a great team of folks back in Atlanta, mostly Atlanta. Andrew's a big part of that, so we appreciate his involvement and participation in our success with Chick-fil-A One. Chick-fil-A, if you aren't familiar with it, is a quick-service restaurant chain. We're the largest quick-service chicken restaurant chain in the United States, a couple of thousand locations, 43 states. And we've been growing for a number of years very strongly. And the takeaway from this slide is that this is a strong brand. We have a really passionate customer base. And I imagine some of you in the room are part of that. We appreciate that. And we wanted to remain relevant going into a digital future. And that is what the premise behind Chick-fil-A One is, that if you know someone's story, you can care for them personally. And big data is a lot of what's behind that. Analytics, I won't go into the analytics aspects of what's behind the platform, not today. But I will talk about the API tier that's driven by Amazon Web Services. And as Andrew mentioned, DynamoDB is a crucial part of that. Behind Chick-fil-A One is, at first, our first tactic is to provide a remote control for your interaction with Chick-fil-A. This is the most personal device on the planet, it's been called, your mobile phone. And so our first goal with Chick-fil-A One is to put a remote control in your customer, in the customer's hands to interact for every digital interaction with Chick-fil-A. And in that remote control, you would be able to have one identity. You would be able to have a consistent experience with Chick-fil-A no matter how you interact. You could start with a mobile app, and you can interact across different channels. and your favorite restaurants, your favorite menu items, everything about your experience follows you wherever you go. And all of that's enabled by a microservices API tier that we'll talk a little more about. This was revealed to the world first time during the week of June 1st, and we had planned to make it a big deal, a big splash. It was the biggest promotion in Chick-fil-A history. And so we put a lot of marketing behind it, and we anticipated a lot of guests coming and checking it out. We were giving away a free chicken sandwich to everybody who downloaded the app and created an account during the month of June. So we expected a lot of people to take us up on that. This we did not expect. We really didn't go into it. There's not a lot of food and drink apps that top out at the top of the free app category on the App Store. We did not expect that. And so I feel like very strongly that Amazon Web Services was a crucial part of success at the unexpected scale. During the launch week, we saw 1 million accounts in the first 2 days, and we saw 2 million accounts before the week was out. We were the #1 app for several days in the App Store and the #2 app in the Google Play Store. And at one point, I was able to see through our dashboard a steady rate of around 750 accounts created per minute for a couple of hours during lunch. And that kind of scale was beyond what we had anticipated. And I'm confident that without the backing of Amazon Web Services, we wouldn't have enjoyed the success we enjoyed during launch. The mobile app interacts with our API tier for most transactions. And behind the mobile app is what we call the digital experience engine. So I actually have a picture of it there. And that's actually a non-production copy. You can tell because you can see the guys, they don't have hearing protection. You can't stand that close to it in production under load. I tell my kids that because it's sort of an abstraction to talk about an engine. But what an engine is, in concept, is the driving force, obviously. And we think that behind the app, the driving force of Chick-fil-A One is the API layer. And the app is just one. We hope it's a great reference implementation. We hope it's an awesome user experience. But we don't think Chick-fil-A is going to build every endpoint. We don't think Chick-fil-A is going to create every interface that our customers will use to interact with our brand. The API tier is going to be the hub for all of that. And just like Werner said in his keynote on Wednesday, it's data that can help differentiate the brand. We should be the best source of information about our brand. We should know what our restaurants are, what are the features, the amenities. We should know what's on the menu and what it costs. And we should know, in the future, we'd like to be able to know what's the lead time for the order that you are placing at the restaurant that you would like it prepared at, so that we can help shape your demand. We can tell you what that lead time is going to be, and we can help on the back end with production capacity to meet that demand in real time. I want to talk a little bit about what goes on when orders do get placed, and a little bit about the scale of that. Besides aggregating data about our restaurants, I think one of the key value propositions of the API tier, it's the only viable route into our kitchens. Our kitchens operate at a scale that's unusual for our industry. I'll put a few metrics up, and these are taken from a fairly high volume restaurant. So this is not every restaurant experience, but whenever you think of a restaurant at lunchtime, if you've seen a Chick-fil-A at lunchtime that's popular, you'll see the drive-through wrapped around the building a time or two. You'll see traffic potentially backing out onto the streets or parking lots surrounding. You'll see every parking space filled, all the dining room tables filled. At that point, we're seeing volumes like that. And it's at that point that each incremental order needs to be carefully managed. How do we do that kind of a volume? There's the kitchen without the text in front of it, and the red circles show you the kitchen production system monitors. What we have in the kitchen is actually a high-volume custom manufacturing facility. I get excited about it. I have 4 kids. 2 of them are teenage boys, and they work actually at a Chick-fil-A close to our house, and they actually work in the kitchen. And so I have validation not only from all the numbers, but I have firsthand validation from those guys. It gets crazy during peak hours in the kitchen. The typical kitchen is a 4-person crew, and they're looking at screens that are customized for their task station. So as an order flows through our point of sale, each line item is routed based on what it is and whether it's a customization or not to a different station within the restaurant. And that's the way we're able to fulfill orders at that volume. So think about partnering with an on-demand or a delivery organization that's going to help us by taking orders and sending them out with a driver for delivery. If that partner brings to us an iPad, just one, and says, let's put this on the wall and this will be your digital order queue, I don't think that's going to work, not at scale. We might be able to test that way, but we're not going to be able to roll that out. We have to come through the API. The other aspect that we haven't talked about is behind the camera in this picture is the food cooking area. And in the food cooking area, we actually partnered with the University of Kentucky at Lexington on lean principles. So this actually is being fed by last month, yesterday, and last few minutes, order activity so that the person breading and cooking the chicken knows exactly how much to drop in real time to keep up with demand. And of course, we can't put an iPad on the wall and expect to put any significant percentage of sales through that with success. So that's part of the value proposition of a digital experience engine. It's the single place to get access to that high volume production manufacturing facility in the kitchen. Now if pictures of restaurant kitchens made you nervous and uncomfortable, here's a nice topology diagram. So we're back in the world of cloud, and this is a sample, a simplified, if you will, sample of the way that a sample microservice would be put together in our digital experience engine. These are the building blocks, the stamp out pattern for a new microservice that we would deploy. DynamoDB for the persistence layer. If we deploy a new microservice, it's going to have at baseline a minimum of 4 servers. It'll be 2 for routing and 2 for runtime in each availability zone. We're in a single region right now. Elasticache is useful in some cases. Whenever we broker interactions with partner APIs, Elasticache is very helpful for improving performance, reducing latency as we interact with those partner APIs. I mentioned that we broker a lot of interactions with different partner platforms. DXE is not, or Chick-fil-A 1, I should say, is not an entirely cloud-native solution. It can't be because of those restaurant kitchens that I just showed you. We have to deal with real bricks and mortar there. We have to integrate with over almost 2,000 small businesses, each of them having their own internet connection. And there are redundancies in place, but we can count on latency issues, we can count on connectivity issues at any time. We're dealing with those for different restaurants. And with the help of Netflix open source components like Hystrix for falling back to graceful experiences, we're able to help the customer experience remain positive, even in the face of that adversity. I'd also mention that when we started the journey a few years ago and we were experimenting, our mobile application interacted directly with all of our partners and with our restaurants through different APIs that we didn't control and we had no visibility into. I would say that consolidating all the API interactions into one place that we do control and we can see was the big game changer for us. It helps us and our partners have much better visibility into the experience that customers are having as they use the mobile application. So this is the right pattern for us, and there was some discussion about creating a centralized point of failure, if you will, but with the right design patterns, with AWS as a partner, with the investment in the right design patterns and the investment in infrastructure, we feel confident that the digital experience engine is able to maintain really high levels of visibility or availability and give us the visibility we need to improve and maintain customer experience. For us, microservices means this. It means that we can isolate and separate concerns. I've given you just a sample, a few of the sample microservice families that we deploy, just to give you a flavor for what one of those might be. They're grouped together in this way. That allows us to iterate quickly, and we are able to deploy if we need to under load. We do not have continuous deployment in place. I would say we'd like to go there, but one of the barriers right now is with testing of mobile app user experience in an automated fashion. We are using the Amazon device farm, and we've begun work on that. But we're probably going to have to take a step back and do some work on the app itself to get to the place where we can do complete continuous deployment with confidence. Because right now the testing effort's still a bit too manual, so that's an opportunity for us. But we are able to deploy very quickly. Really the testing and assurance part is the longest, but we can go from concept to deploy with new functionality or with a fix, definitely same day, and we've done that before. It's a great flexibility to have. There's also choice of implementation language and infrastructure. It is Java right now. We're really at the brink of bringing on new languages, and we have in particular going beyond servers. So we would like to bring up endpoints that are Lambda enabled going forward. Werner mentioned 12 factors a couple of times in his keynote address, and we have been heavily influenced. I think of 12 factor as the set of principles that point you towards cloud infrastructure and cloud native design. And they enable full automation, encourage full automation of infrastructure as code. One key factor that has been crucial for us is that you have one code base that behaves differently depending on where it's deployed, and it's influenced in doing that by environment variables rather than by the code base itself. There should never be any conditionals or control statements that are environment aware. Everything's tokenized, and the environment around the code will influence the behavior. We also invested in features that we're turning features on and off selectively based on context, using that environment, using environment variables. I showed you a really simplified building block view of a single microservice earlier. This slide is to point out that that's not all we use in the catalog of Amazon Web Services. We really rely upon a lot of things, and they may not even all be listed here. What I did with this slide was I stacked these purposefully in a way that shows how I like to think about them from building blocks, the primitives, if you will, and they get more valuable from a business standpoint as you go up. And they require less from an operations standpoint as you go up in the stack. And Kinesis has been awesome as we've gotten into that. Lambda has been tremendous for operations automation. And of course, Elastic Beanstalk abstracts a lot of the infrastructure so that we don't have to spend a lot of our engineering cycles thinking about daily operations. Some specifics about launch week. Leading up to June 1st, we were running on a baseline of about 75 servers. They were in the T2 small category. At peak, during launch week, we hit 225 servers before we changed some things. We really hadn't anticipated that level of load. And again, I'd say without Amazon behind us, that would have been a problem. Because as you know, I spent many years working with traditional data centers, and if you underestimate your load there, it's just not really something you can recover easily from. We were able to see that happen and just take notes on what was going on. We were able to see some hotspots where we really needed bigger instance types, and we were able to make those changes. We waited until an off-peak time. We got our auto-scaling to come down to the minimums in the Elastic Beanstalk environments, and then we were able to change the properties of the environments, pick new instance types, and that was done for all the service tiers and deployed across the environment within 30 minutes. And that's pretty remarkable because if you needed to change the hardware behind your services in a traditional data center situation, that's not something you would be able to do within the life cycle of our 1-month promotion. Traffic would be gone by the time you got that done. I also wanted to mention, before June 1st, we had several months of iteration and market testing, and we had different patterns, and we had different software that we were working with. And I wanted to talk a little bit, I think you've heard some of this message before, but if you're thinking about going down this road and you're accustomed to working with traditional enterprise software in your data center and you've had success with it, watch out for the differences that come as you move to the cloud. I call it cloud native where you'd like to be versus cloud clumsy. And you might have cloud clumsy software if you're talking about counting CPUs per year instead of per hour. You might be talking with a cloud clumsy software partner. And if you have a single SKU that has all the features that the vendor offers and they're deployed to every CPU and charged per CPU, then you might not be happy as you scale out, as you face a citizen scale use case. Now, the specific partners I'm talking about, we still work with them and use them, and they're great for the use cases where scale is not required. So I'm not throwing them under the bus. I'm saying that you need to choose partners carefully based on the use case. And whenever you have high scale and you're deploying in the cloud, you're going to find problems here. The last thing I'd mention in this category is administration. If infrastructure is code, you need to be able to automate every aspect of it. If there's anything you cannot automate, anything requires you to pull up a web interface and make a change with a mouse, that's not going to be successful at scale. That's not going to enable you to have your failover transparently. It's not going to set you up for fully automating your infrastructure and getting your operations down to where it needs to be. So I also want to shout out for the picture there. I kind of like steampunkish things. This is from Jekyll Island Chronicles, and that's a book published by some friends of mine at Chick-fil-A. I thought this captured pretty well what it might have felt like if we had gone into June with some of those software components in there. We did not. We got rid of those components. We adopted patterns that were cloud native. Then we wanted to make sure they really would scale. I've heard some good advice through the sessions here about never trusting other people's benchmarks. I would agree with that. We definitely wanted to see it proven out with our own use cases. So we did some forecasting of what we expected. It was actually less than what we saw. But like every good forecast and every good load test, we doubled our estimate. So we really tested pretty close to what we saw as far as load. We just didn't expect to see it in production. And we did know, we had confidence going in that the infrastructure was going to scale to meet that load. Engaging AWS support was, I feel like, very important. We cleared some barriers that probably would have been pretty noticeable to customers and would have affected service levels. We did not at the time have an enterprise agreement with Amazon support. So we engaged them using their infrastructure event management service, I believe it's called. And it was definitely worth the price of admission if you're thinking about that, if you're working towards a specific major promotion and you are doing this for the first time, as we were. It was a great investment. Just the questions, they were able to assemble a set of subject matter experts based on the profile or the collection of Amazon services we depended upon for critical use cases. And those SMEs were on a call with us asking questions that we could not answer. And that was part of the process. We had to go do our homework. We had to dig in and answer those questions. And in providing the answers, that was part of it. We didn't have good answers, and we had to create good answers. So I feel like the process of engaging Amazon support was also a crucial factor contributing to the success, and encourage you to learn from that. Visibility was also a major part of success. What you're looking at right now is a screenshot, actually a photo, of the second day of our launch during launch week. And this was a Splunk dashboard. This is about registrations. We had others that were focused on mobile ordering. And this one is showing registrations and the pace of registrations. Amazon offers services like this now. Managed Elasticsearch can provide visualizations. I would really encourage you to look beyond CloudWatch logs and the graphs that it can produce. Look for ways to visualize and get these compelling ways of seeing traffic and business activity in front of your business stakeholders and in front of your operations teams so they can respond. The business also needed visibility beyond marketing, which was our partner through this, of course, but supply chain was very interested in real-time order information and registrations, because that has a lot to do with chicken. You really don't want to run out of chicken when you're trying to give chicken away. You never want to run out of chicken, but especially if that's your promotion, you really don't want to run out. And so supply chain was very excited. They had people in the room taking notes, making phone calls to make sure that we could fulfill our promises. And obviously, given that we were exceeding the expectations of the business, we had to make some phone calls to make sure that we didn't run out of chicken. So again, to recap, here's some of the things we learned. Open source or cloud-savvy software partners. Warning about DynamoDB, it's great, as Andrew said. One thing it does not do at this time, out of the box, is scale itself up to meet demand. It relies on you to do that. You can do that through API calls. You can do that automatically within your code. Or what we chose to do is make that, eventually we invested, we found some open source components that someone else had come up with, and we were able to scaffold around DynamoDB key tables that we expected to need to scale, and we could dial up capacity to meet the ramping demand. Because with DynamoDB, you are paying for the provisioned capacity, not the capacity that your app is using. So you need to manage that wisely and prudently. So investing in some scaffolding around DynamoDB was good for us. We learned that deploying to a live Elastic Beanstalk environment does have risks, and there are some limits around that. And specifically, we saw cases where, at scale, when we were running 12 and 14 instances in an environment, and we would deploy code under duress. We don't really like to do that. But at times, that would take longer than we expected, and at times we had to engage support. An instance would perhaps become unresponsive, and we eventually found root causes for those things, but it gave us some cautions. And the way around that is, rather than to deploy live to your running environment, and we knew this, but it takes time to build the engineering around it. It's blue-green or AB. There's various ways to describe that, but to establish another environment that you can switch over to so that you don't have the challenge of rolling an update through each instance of your cluster. That leads to a different challenge as you do blue-green, and we did experiment more with that through June. And when you set up a new environment with Elastic Beanstalk, if you're under load and you shift the load, you shift the traffic to the new environment, you may find that the elastic load balancers are not yet ready for that level of load. They need some time to scale up. So if you don't have a means of gradually shifting the load over, and we were using a simple approach, which was Route 53 DNS changes, which was instant and complete. Unfortunately, that doesn't allow the elastic load balancers the necessary time to be ready for that load. And there's some, you might have some HTTP response errors as customers don't get responses from the ELB group. To deal with that, part of the infrastructure event management engagement is that we identified all of the ELBs that were part of the critical Elastic Beanstalk environment. And the support organization is able to pre-warm those ELBs so you don't have that issue. So the fix for you can do blue-green while you're under load, you need to work with support to make sure that the ELBs are preheated if you're using DNS for abrupt cutover, or you may invest in some routing logic that can shift load more gradually and give you a more graceful cutover. We've also made a lot of investment in the ability to pilot and to test new features in a very granular way that limits the impact. And some people call that a canary approach. where you deploy a new feature, but it's not on, and then you turn it on at the pace you want it turned on. So we've built that into the code itself. And this is pretty specific to our domain and our situation, but we're able to test features for any arbitrary group of users, any arbitrary group of restaurants, or a union of those. And we're continuing to invest in that because we like that a lot. It gives us a lot of flexibility to experiment with new features and see what the response is. Visibility, we talked about being key. It's worth investing. It's worth the time. And the last one is a very tactical observation, very tactical learning. If you're using Splunk, the Splunk app for AWS, under the release that we were working with in June, it uses the CloudWatch API to fetch logs. And that is actually rate limited. I didn't put it in my notes. I don't remember the limit. But it didn't show up in testing because we didn't test Splunk at load. Perhaps we should have. But it showed up on day one as all of our dashboards were, by mid-afternoon, it was evident that they were lagging reality significantly. And what we were experiencing is a subset, a sampling of the logs. Now, Splunk offers log sampling as a feature, but this was not intentional. We were expecting to get everything from CloudWatch. We did not. And this was an issue we had to figure out very quickly. And what we turned to was DynamoDB streams. It was a great solution. We were able, now we still couldn't get the logs. It took us several weeks before we found a mechanism that actually ingested all of the CloudWatch logs into Splunk. Long story, won't go into it right now. But I would say the DynamoDB streams is a great example of something that worked. We were able to use a Lambda template that Splunk provided and turn on DynamoDB streams for a handful of key tables that gave us insight into business activity like registrations and mobile orders. And the DynamoDB streams we sent to the Lambda called the Splunk HTTP event collector, and that worked. So on day two, our dashboards were refactored into the small hours of the morning, and day two, they were accurate. So that was just a bit of a war story and a lesson learned if you are going to implement with Splunk. Since then, we've set up Splunk in a much more robust fashion. We have an auto-scaling group of HTTP event forwarders, and that is not an issue at this point. But it's a good thing to learn, good thing to know if you're going to do that. Next for us, we think that we need about 6 million menus, and we're already started down that road. So for every customer that's registered, for every active user, we want the menu to be a personal experience. Instead of just everything we offer, we obviously want you to be able to see that, but we want the menu to be increasingly personalized. And not only based on what you have ordered, but what you're likely to enjoy. And those sorts of things are made possible by looking at the data we're collecting and taking advantage of it. Again, differentiating with the data. We see 100 different ordering interfaces. I mentioned that before. We don't think we're going to build all of them, but if we're ready for conversational ordering, and if we're ready for ordering in cars and with devices that don't exist yet, we think some of the folks in this audience will be helping us do that. Delivery is another, obviously a hot area, and once we solve the challenges associated with getting orders into the kitchen at high volume so we can produce the food and meet the customer expectations, we'll be ready to talk about delivery. We're testing that in several places now. In-restaurant engagement of customers through beacons and general IoT approach to knowing more about the restaurant environment, knowing more about what's going on in the kitchen and in real time can help us make better decisions and help shape help shape production to meet demand and meet customer expectations. And we do want to invest in fully automating our blue-green deployments. That's something that's on our roadmap, as well as using another region beyond US East where we are today. We started with very few services, really, and we didn't see a need to invest in service discovery. But as the collection grows and as we go beyond the set of Java services that we have today and we look at introducing serverless and we look at introducing other languages, then it makes sense to us to begin using a service discovery layer. Netflix Eureka, we really are big fans of the Netflix open source components and use several of them, and this would be another one we think we might fold in. And I mentioned already that going beyond Java, looking at Lambda, exciting announcements this week for some things that might be in our future. I'm pretty confident that this will be the best session that you attend this afternoon. So I want you to make sure to tell us about that. And also, if you are here and you'd like to connect, come on down front afterwards. You can see my email on screen. I also have, if you have not tasted our frosted lemonade, I encourage you to come down front. And while supplies last, you can bring home a digital offer card good for one frosted lemonade. And I would love to connect with you and answer any questions down front. Thank you for your time.